Welcome to the satellite communication course. Now we'll continue the discussion here with a TDMA transmission to the satellite, and we have said that a TDMA bus synchronization, how that synchronization is takes place here. So now, as we say that there are the number of stations, they transmit the data to the satellite, so that different Earth station locations are different. So due to the different location of this station, so now data transmitted to the satellite will arrive at this satellite with a delay, and that will be arrive with a different times, because delay is depending upon that range means what? Distance from the satellite to the earth to the satellite. So different earth station, they have the different distance, so that's why the delay will be different. So now, because of the different delay, so data bus from a station, earth station here, that will be arrive at a different times on this particular uplink. So now these are nothing but a, just we have say that these are the data bus from this earth station. These are the data bus from the earth station here. Now these are about the station, reference station A, B, C. These are transmitting the data bus. And again station D, these are about the uplink data. So now at this place, it will arrive. These are the uplink. From the different earth station, it will arrive at the satellite at the different times. So that's why there is a probability that the bus from the different station may overlap on each other. So simple, I am saying, suppose we have the different transmitter and receiver here, as we have seen earlier, that is a bus here, bus A, bus B, bus C, likewise. So now it is different bursts are there, but at a receiver, so, so bus A, in that bus A, we are receiving C and B, C, D here. But due to the difference in the earth station, delay, different position of earth station, so delay will be different. So arriving that bus may be overlapping. So likewise, suppose this bus C and B, likewise this may be overlap. Okay. So that's why we need to know here at what time these stations are transmitting the data. So that's why it is necessary to synchronize the bus. Okay. It is necessary to synchronize the bus with respect to the reference bus, so that at the satellite, all the bus are, whatever the bus transmitted from the earth station, they will reach with the exact location allocated to them, or exact timing, or exact locations in the frame allocated to them, with a tolerance of one or two symbol. So that's why that reference station is necessary, and so that's why that bus is arrive at this particular satellite with a specific time allocated in that particular frame, or a location in that particular frame. So that's why if we synchronize that bus, or synchronize that transmission of that bus there from the different station. So the bus will maintain that position in the frame. Okay, means you can say that this is about A, likewise B, likewise C, likewise D. So no overlap will be there in that particular frame. So that is about that bus will maintain the position in the frame, and according to that, that same bus will be transmitted to the downlink here. So now, for example, I am just saying now this one is about A. Okay, A here, likewise A1, A2, A3, A4. This one is about a B1, B2, and a B3, C1, C2, C3. Here we can say that D1, D2, and a D3. Now, when this arrives here, that bus will arise here. So it has what? It is about a reference station A here, and then B, and then C, and then D likewise. So A, B, C, D. So then again, this one is about a reference A, then B, then C, then D, then A, then B, then C, likewise. So means at the in the downlink, they will arrive in the form of what? Whichever the position is given in the frame, and that's why they will arrive likewise ABCD format in that particular frame. So means that four Earth stations are transmitting the data to the satellite, and that will at this downlink they will receive the data. So means downlink station and the downlink station D. Okay, downlink that is about station D is used to act as a receiver here, and that contains a bus from all other stations. So that's why that a synchronization is what? To place a data bus accurately in the allocated position in that particular frame. So means we can say that a transmitting station that must that should know, or that they should know that what will be the exact range of the satellite from its location, and they should have the knowledge of that what will be the delay, that range as well as the delay, and so what will be the timing that data from the station to be transmitted to the satellite, and so that a particular that in that particular frame a precise time or a precise location in that particular frame they are getting. Okay, so likewise, so we supposed to be B is transmitting, so B should know that a station that B should know that what will be the delay, what will be the range, and what will be the position in that frame that data is to be reached, or location at what time that is to be reached there. If burst is placed accurately at that particular position, so then there won't be any overlap, or then nothing will occur, means that will be asynchronized one. If there is a small delay or a small drift occur, so what happen? That particular position of that frame for the given station will not be achieved by that particular station. So that's why there will be a overlap occur. Now that is about a condition, ideal condition we consider. But sometimes, so there may be a drifting of a satellite or position changes of the satellite because of the disturbance. So due to that disturbance, there may be a drift in the satellite position in the given orbit. So that's why we need to know that that Earth station, they should know that what will be the drift position of a satellite. To understand that a drift position of a satellite in a given orbit, so one pulse is to be sent, transmitted from the Earth station to the satellite, and then identify that where is the position of the satellite. So means that is nothing but a Doppler effect, and that Doppler effect, that will be identify the movement of a satellite in the given orbit. So that's why it is necessary every time we need to know that what will be the exactly transmit time required for the station to train the data to the satellite there, so that exactly location of the particular station or that particular bus can be obtained accurately there. So there won't be any overlap of this particular bus. That is about a transmission data. So this one is about a bus synchronization rule. Then what will be the component of this initial acquisition here and this unique word detector that we will see one by one here. So now if you see that a initial acquisition system, so it transmitting and receiving pulse during the initial acquisition. This is about a transmitted pulse. This is about a transmitted pulse. Okay, and this is about a transmitting frame, and we can say that these are about a transmitting pulse at a different location. Okay, these are about we can consider. And this is about a delay, satellite path delay. Means this is about a transmitting station, that Earth station, and then that pulse is transmitted to the satellite. So that is nothing but a what? A satellite path delay. Okay, this is nothing but a satellite path delay. That is about a KTF plus delay. Now, why this initial acquisition process is required? So that initial acquisition process, that will require to place the bus, that is required to place a bus in the allocated position. Okay, that is it is just like initial acquisition process is nothing but what? It is to place the bus in the allocated position or maintaining that place in the allocated position. Okay, place the bus in the allocated position as well as maintain that position in that allocated position there, and that will be done through the reference bus. So that's why we require the bus synchronization. So in that initial acquisition phase, so that's why we, that allocated time slot in that particular frame is there. When we can say that when that earth station transmit the data to the satellite, so in that case we need to transmit some particular pulse, and then we can find out that whatever the position or a location of that particular pulse is. So means generally we say that a earth station transmit the burst of a data, and that particular burst is to be allocated one particular position, and that position can be can be obtained through the reference station. Okay, so earlier we have seen this one. We have the reference station. This is about a reference station here. That is about a reference station. And then from this reference station, whichever the allocated position of that particular bus can be obtained from, okay, from this particular reference station there. So means a synchronization takes place, or we can say that a acquisition, it takes place using this reference station. Okay, and that acquisition or a synchronization method, we can say that they are a two different method. There are two different methods, and that two different methods of acquisition and synchronization, they have the open loop synchronization, or you can say that open loop acquisition here, and a closed loop acquisition. Okay, that is about acquisition. They have a open loop acquisition and a closed loop acquisition method. So in that case of a open loop acquisition method, so we need to know about that exact delay from the earth station and a satellite. So means we can say that we need to know about that what will be the exact delay here in the case of a open loop. And once we know that what will be the exact delay, or there may be a small variation, or we can say that there may be a delay of a one or two symbols, and that can be calculated using this open loop acquisition system. In a that is about the open loop acquisition system. If supposed to be there is a small variation in the delay, then what happened that, so there may be a small delay in the a bus transmission, that location there. So that's why we need to calculate every time what will be the a delay in between that earth station and a transmission there, so that a position allocated in that particular frame by this reference station, and that particular bus located at that particular place there using that particular reference station there. Now this one is method. It looks like a simpler one, and it is very difficult to obtain that what will be the delay, because the satellite position will be drift because of that any external disturbances at the satellite orbit. So that's why the position of that satellite in the given orbit will be changes. So that's why the delay will be different. And that is about a open loop system. And in the case of a closed loop acquisition method, so in this case, it will continuously monitoring. Okay. So it will be what? It will be continuously monitoring and measuring the error position of the local bus in the receive frame. Okay, that is about a closed loop system. So that whatever the corrections required at the transmitting side, that will be corrected there. Means we need to know about what will be the error, and according to that we will correct that particular position. And then whichever the receive frame is received, and that frame is marked by the received unique word. Whichever the frame is there, that will be marked by the received unique frame word synchronization. So likewise, this is about a bus synchronization. We have the initial equation. So that's why we require that a receive unique word pulse, and that particular pulse that will be useful for the identifying the what will be the delay from this receive unique word, so that the position of the start of the local bus in the receive frame that will be marked by counting the symbols that will be corresponding to the delay there in the RUW pulse. So that's why a initial equation pulse or initial equation of that particular time slot that will be achieved by using this open loop method or a closed loop method, or we can send a one particular pulse or transmitted pulse is transmitted, and that pulse is transmitted with a frame of what we can say that is about a TF period, and its position in the received frame with respect to whatever the local bus is measured, and the transmitted frame, it has a period of what that period is obtained from this a modulo n symbol counter here. So that's why we can say that a n is equal to what, that is about a frame period, that is about a ts, and we have a frame symbol ta by ts there. And that width of that particular whatever the pulse we say means we have a particular transmitted pulse and a particular it will be received at the receiver pulse. So transmitted pulse width and received pulse width, if you compare that the pulse which is received at the receiver, that will be larger than that whatever the transmitted pulse. So now when the pulse is transmitted from this station, so there may be a delay, and then it will be received at this particular receiver there. And we doesn't know that what will be the delay or a round trip delay from the earth station to the satellite there. So when a pulse is transmitted, that pulse is shifted, and that pulse is shifted by some particular frame, and that particular transmitted pulse is shifted in that particular frame by a ta second. Okay, so we can say that because of that particular delay, that pulse will be shifted there. Now in this case, if you see here, we have this received side, we have a received RUW word. This is a received RUW word. This is about a LUW position, and this one is about a received pulse. This one is about a received pulse, and in between this is about a NE, that is about the error. Okay, NE is nothing but the error here, and N is nothing but what, a number that is about a N symbols, and this one is about a receiving frame or a frame. So means we can consider that a satellite path delay is of what, a KTF, that is about a K frame, and that will be of a delay of what we can say that K, and that can be obtained by this K is equal to what, DS by TF, and that DS is nothing but that a satellite round trip delay, and that TF is nothing but a frame period. So we can calculate that KTF here, and this particular a delta T is a drift in that particular a path here, satellite path. So that is about a satellite path delay. This is nothing but what, a KTF plus del T. Okay, that is about a satellite path delay. So that a acquisition pulse, if when it will be received, so then what happen? That receiver detects first whichever the RUW and a LUW pulse. Means we can say that a receiver detects that a local unique word pulse, and that is up at a preamble in the whatever the that frame we have in preamble in the particular frame here, and that a position of this particular LEW pulse with respect to that RUW pulse, that will give the exact position of the local burst in the frame there. So small adjustment in that particular local burst, that will be carried out by the burst synchronization, and this is about a receiving pulse, and we are getting that error of this particular received pulse, that will be n here. Now you can consider here next about a sequence of the transmit frame length during the correction pair. So Tx frame n minus 1 symbol, Tx frame n plus k symbol, and that is about another frame transmit frame of a n symbol. So received pulse is observed in the aperture at that particular location in the frame, and that received pulse have the a pulse repetition period, and that period is fixed with a TF period there. So now if you consider that initial acquisition system, so in that case the initial acquisition system, and that initial acquisition system in what, here we have a TDMA terminal equipment, initial acquisition system or initial acquisition modem here. Now in that case it has a two counters, one is about a transmitting counter, another is about a receiving counter, and that two counters are independently generate that a receive frame as well as that a transmit frame. Missed. Here is about a transmit frame counter. This one is about a receive frame counter, Rx frame counter, TX frame counter. And this one is about a symbol clock. Okay. So we have the a symbol clock, and then a there is about a frame counter generated, and that a received frame counter that will be synchronized to the RUW pulse. This is about your RUW pulse, and that is used to generate the aperture through which that received pulse, initial equation pulse, is generated. Okay, so that's why, so we can say that it is used to generate that aperture, and then it will that then it will give that initial equation demodulator here input, so that the initial equation pulse that will be generated, that will be detected at the receiver here, and that aperture is generated here, and that aperture generated at the center of the local bus slot. And in the case of a transmit frame counter, so that is nothing but a gen it generates that a initial equation pulse, and then we, through that a counter it will use to generate that initial equation pulse, and that initial equation pulse that is to be transmitted, and the transmitted frame, it has a frame, and that frame has the transmitted pulse has a frame, and that frame length is calculated from this frame length controller, and that frame length controller is to generate that a frame pulse that will be period of a TF, TF minus TA, TF plus KT second. So that's why that particular counter generate that initial equation pulse, and that initial equation pulse is transmitted using a amplitude shift keying or a BPSK modulator. Okay, this is about the initial equation pulse, and that will be transmitted to your synchronizer here. Again, we can say that is about a modulator. Okay, likewise, we have a unique detector word here. Okay, likewise. And once that at the receiver side, so initial equation pulse is detected in the aperture. So in that case, that frame period will be what? A TF plus KTA. So that when it is to be set, then it is to be detected there. And it we have this frame that is about a transmit frame, and we have here the a receiving frame pulse. Okay, so that is about a TX RF pulse and a RX RF pulse. So that initial acquisition process of that particular local bus can be carried out using that pseudo random generator also. So means it consists of that pseudo random data or a sequence, and it has the information of the ones and zeros, and according to that it will generate that transmit pulse as well as the receiving pulse. Then another component of this a TDMA terminal equipment That is about a unique word generator. So you can say that a unique word detector, not a generator. It is about a unique word detector. So that a unique word detector here, it has a shift register. This is about a shift register. This one is about a data input, a modulo to adders, unique word storage register. This adder. This is about a threshold comparator, error threshold, and it will detect that unique word detection pulse. And this is use unique word detector. So that is used for the detection of the RUW and a LEW pattern in the whatever the data. So this unique word detector, it will generate a pulse. That pulse is called as a unique word detection pulse. So because the different unique patterns are there, they are used at different reference stations and different local station. So that's why the pattern for all the stations, it should be the same. So that's why this unique word detector is used for this particular station, and it will generate that a unique word detection pulse there. So if you consider that it has a just like a shift register, it has a modulator adder here, it has a threshold comparator here, and that length of this particular shift register is same as a length of that unique word, because we have the unique word storage register here. So that's why the trip shift register length and that unique word storage register both are the same. So that's why that whatever the received data, and that received data, that will be shifted through a one register and the other register, and that will be stored at this unique word stored register. Okay, this is about a UW storage register or a UW storage symbol. And then at each and every clock period, the data bits are compared with the stored bits. Okay, this when we can, and then this is about nothing but a comparing the whatever the unique was storage register data. So means once it will be compared, and then we'll get the output that will be given to the adder here. Means whatever the output we are generated through this XOR operation, that will be added here, and the row then the output of this particular adder, that will be compared here. So if the received pattern, if it is exactly same as the stored pattern, the output adder will be equal. So that's why that output of this particular adder will be a 0. And if that output is equal to 0, that will indicate that there is a perfect match between that two words. If it is not match, then there will be some output. One, there may be a two situation arises in that particular process. If that received pattern have some particular error, suppose, so means adder output will show some particular output here, and then the comparator will detect whatever the unique word detector. Okay, means there is a small difference, and then that error will occur. So that is nothing but what, a unique word detection miss, or a detection miss. If the received data pattern, if it is identical to the unique word pattern, so then what happen? That comparator output may show the detection pattern that will be transmitted by the transmitter. And if supposed to be, it is that pattern is not that supposed to be unique word pattern, so then there will be a path detection. So that's why we can minimize the detection misses by some particular errors. That errors used to be tolerated, so that we need to adjust some particular threshold here to accommodate that whatever the errors are there in that unique word pattern for the false detection. So to minimize the false detection here, the detection pulse is passed through an aperture, and then that will be give that expected location of that unique word. So that's why there are the two detectors used. Okay, in this way, and that two detectors are used for detecting. One is about the RUW, and another is used for the LUW, local unique word. Means two detectors are used, and that two detectors will generate that LUW and a RUW there. In the RUW detector, that aperture is kept wide open until that first RUW pulse is to be detected. And once that RUW is detected, so then it will allow that RUW pulse. So that's why the next about we can say that a LUW pulse, and that RUW and LUW pulse, that will be used in that particular frame, that TDMA frame, and that they are allocated in that particular frame, and that pulse is generated. Okay, so I'll just show you that here we can see that UW bit, unique word bit. I'll show you that a RUW pulse. So in that particular preamble here, that is about a control bit we have. So that RUW and a UW bits are there. Okay, that is about a unique word detection process in the, we can say that, in the TDMA format. So that's why you can consider that here, if we have a reference station, and this one is about a local station, so that a synchronization is done after the acquisition of a pulse that is detected for a particular frame. and then station transmitting that preamble, and then that in the middle they have to place the equation pulse, and then it is to be transmitted there. And then station decodes that LUW words that will be transmitted in that particular preamble. So means we have a reference bus. So we can say that reference frame counter, then our reference bus transmitter, then delay, reference unique word detector, then RUW pulse. Here is the detector, and then we have a control circuit here, and that will detect that a local unique word. Okay, likewise. So we can consider that a reference station and a pulse station here. So reference station, we are transmitting that reference pulse, and then we are receiving that particular pulse here. And that is about a reference bus is transmitted from the reference station, local bus is transmitted from the local station, and it is receiving both the reference pulse, reference bus as well as the local bus there. And here then they will correct that particular RUW word as well as the LUW word, and a corrected position using this reference bus and a local bus transmission takes place in between the two stations there. Again, so now that reference station is here, so satellite delay is to be obtained from this reference bus, or a local bus is transmitted, and then both are received on the downlink there. So there may be a delay difference between, because there are the two different stations, so there may be a delay difference. But so that will correct the position of the LEW, or the difference between these two particular frames, that will